We're looking at a midterm exam, specifically Unit 1, Chapter 3 questions that would be on the midterm exam. It's the probability section. If we look at multiple choice number 18, the odds of randomly selecting a red marble from a bag of colored marbles is 5 to 8. What is the probability of selecting a red marble? So we're going from odds to probability. We're going to go from odds to probability. And so we can see that if it's 5 to 8, that means there are going to be 13 marbles in total, and 5 of them will be red. So the probability of getting a red marble will equal 5 over 13. Twelve adults were surveyed and asked how many children they had. The results are below. If one adult is chosen from this group, what is the probability that they will have at least one child? Now I want to remind you, this one is a little bit tricky on the wording. This one means that we have an adult that has one child, another adult that has 3 children, another adult that has 0, an adult that has 2 children. So if we're looking for an adult, if we're looking for the probability that an adult will have at least one child is right here, right here. So 8 out of the 12 adults surveyed, giving us 0.666, so on. So the percentage would be 66.67%. Multiple choice number 20. A hockey player has taken 21 shots and scored 6. What are the odds against the player scoring a goal on the next shot? So we're going from probability now to odds. So you see that the probability they will score is 6 over 21. That's the probability of scoring. The probability of not scoring is going to equal to 15 over 21. We also have to remember that this has to be, probability should be expressed in lowest terms, as with odds should be expressed in lowest terms. This will be 2 over 7, this being 5 over 7. So the odds against would be 5 to 2, since they will not score 5 and score 2. Which experiment involves independent events? And if you recall, independent events are 2 events that do not, the probability of one event does not affect the probability of the other. Driving while texting and having an accident, one could probably depend, the probability of one happening will affect the probability of the other. Rolling a die and flipping a coin. These are definitely independent events. Let's just check the rest. Rolling a die and getting an even number. They're dependent, since there are 3 even numbers on the die. And studying math and passing the test. So studying math and passing the test, those probabilities can be determined from one another. So we have the, on a standard 6-sided die, which is rolled twice, what is the probability of rolling a 3 and then a 5? So you want these 2 events. This is the probability of independent events. Since rolling 2 dice, or rolling a dice twice, are 2 independent events. It's independent. And we have a formula given on our formula sheets for the probability of independent events. So the probability of A and B, given that A and B are independent, is the probability of A times the probability of B. So we have the probability of rolling a 3 is 1/6 times the probability of rolling a 5 is 1/6. This gives us C. This may be appealing to you for an answer since we have 1/6 plus 1/6. That would be the probability of rolling a 3 or 5. The student council has 7 members, 3 males and 4 females. 4 members are to be chosen at random to attend a conference. Which expression represents the probability of at least 2 males? So here's the condition. And once again, this is similar to questions from Unit 2, but we're asked for the probability. So we have to put that over the total. With a committee, we have 4 females and 4 males. Order does not matter, so the permutation answers will be out. These committees will involve combinations. So we have at least 2 males. There's certain cases for at least 2 males. You could have 2 males and 2 females, or you could have 3 males and 1 female, or there's 4 members. Could you have 4 males and 0 females? And the answer to that would be no, because there is only 3 males to choose from. This is the only 2 cases we have. So since there's 3 males to choose from, we have 3 choose 2 times, and there's 4 females to choose from. So they're going to take up the other 2 positions. Plus, we have 3 males to choose from to go into 3 positions in this case, times the 4 females to choose from to go into 1 position on the student council. So this is what we want. This is the outcomes favorable. The total number of outcomes, there are 7 members. So 7 members to go into 4 positions. And so we have, the answer would be B. The probability that Sean will go to the hockey game on Friday night is 0.4. The probability he will go to the dance on Friday night is 0.5. The probability he will go to either is 0.8. This sounds like a lot of the examples we have in Unit 1, and hence a Venn diagram is going to be useful in determining the probability. So we have, he's going to the hockey game and the dance, and we see the probability that he will go to the hockey game or the dance. Says the probability he will go to either, which is the union, that implies a union, is equal to 0.8. The probability he will go to the dance, is 0.5. The probability he will go to the hockey game is 0.4. This gives us a total of 0.9. Yet, the chance he will go to either is 0.8, giving us these events are non-mutually exclusive. It's going to give us 0.1 in the intersect, giving us the probability he will only go to the hockey game would be 0.3. The probability he will only go to the dance would be 0.4. So this is, what is the probability he will go to the dance and the hockey game? That would be 0.1, D. So we have the probability of non-mutually exclusive events here, and a Venn diagram can help us. Bob randomly selects 2 cards without replacement from a deck of 30 cards shown below. What is the probability of him selecting a red and then a blue? So we have If he's selecting cards without replacement, that implies dependent events. Dependent events. So the probability of two dependent events is the probability of dependent events, two things happening, if they're dependent, of course, is equal to the probability of A times the probability of B given A has already happened. That's conditional probability. So we have these. The probability of A will be the probability of selecting a red. There are, as you can see, there are 10 red cards, okay, out of a total of 30. So the probability of getting a red card will be 10 over 30. The probability of getting a blue card, given that you've already selected a red, well, there's still 10 blue cards left. But since you've already taken one out and did not replace it, there's 29. This gives us 100 over 870, or 10 over 87. Looking at a constructed response item, we have the probability of Bob and Chris standing next to each other when considering the total possible arrangements of Andrew, Bob, Chris, Dave, and Eric in a line. So we have the 5 guys stood in a line. The total number, remember, we're asked for the probability. Once again, it looks like a question from chapter 2, rather. Yet because it asks us for the probability, we have to put the outcomes favorable over the total number. And if we look at the total options to us is that there's 5 options to go in the first position in line, 4 for the next, 3, 2, and 1, which gives us 120 ways of lining the 5 guys up. Yet we're looking for how Bob and Chris can stand next to each other. So we can have Bob here and Chris here, or we can have Chris here and Bob here. So that means that there would be 2 options for the first one, leaving only 1 option for the second, 3 for the third, 2, and 1. This gives us a total of 12. Yet, Bob and Chris can also stand next to each other in different positions in line. We can have Bob here, Chris here. We can have Bob and Chris right here. We can have Bob and Chris right here. So we have 4 different options, 4 different places in which Bob and Chris can stand together. So we have 12 times 4, because each time it's still going to be the same options, which gives us 48. So the probability that Bob and Chris can stand together is going to be the 48 over 120, which gives us 2 over 5. John likes to jog. If the weather is nice, he is 90% likely to jog. If it's raining, he is only 30% likely to jog. The forecast tomorrow indicates a 60% chance of rain. What is the probability he will jog tomorrow? Well, this is conditional probability. And so we have the probability that he will jog So if he's 0.9, he's going to jog on nice days. And tomorrow, it's a 60% chance of rain. So that means it's going to be a 40% chance it'll be nice. That will give us 0.36. This is conditional probability. Yet John will still jog. John will still jog if it's raining. If it's raining, he's only 30% likely to jog, and tomorrow there's a 60% chance it'll rain. This gives us 0.18. So he can jog when it's nice, and he will jog when it's raining. The total will be 0.54. Or tomorrow, he has a 54% chance of jogging. We have Statistics Canada reports that 92% of all Canadians regularly watch videos online. Of these people, 60 watch videos on a mobile device. What is the probability of a Canadian person regularly watching videos on a device that is not mobile? So we have conditional probability. And in this case, we have 0.92. So of the people that watch videos, of the Canadians that watch videos, 60% watch on a mobile device. That gives us 40% that are not on a mobile device. This gives us 0.368, or 36.8%. So while you're doing questions that involve probability, make sure you're able to identify the probability of mutually exclusive events and non-mutually exclusive events, and we can use Venn diagrams to help us with that one. Make sure we know when we're determining the probability of independent events, and once again the formula for probability of independent events will be given to us. And conditional probability. Make sure we're able to identify problems where there's conditional probability.